This is a data set of FIB-SEM, which I downloaded from here. It's a public data set. Everyone can use it. Well, basically it's a HeLa hair cell, the FIB-SEM image stack. What I wanted to demo is the slice registration. Well, there's nothing very fancy today. I just want to demonstrate the basic workflow for FIB-SEM data. This one doesn't have much artifact like the stripes. Maybe it has been corrected first, but we see a lot of shifting from slice to slice, drifting. So the first step is to do the slice registration. We have many algorithms or methods for that, and the most common used are either SSD or mutual information. Like SSD is the summary of the squared differences. So it measures the two images intensity differences. So I can use a box. This will restrict my computation of the SSD. I want to use this region with my effective region for alignment. So this one I use fixed because it doesn't move too much. The box itself should be okay for all slices. So I can start with the offset, the small offset. So those two views, I mean, the big one on the top is the image plane view. The bottom two views from the other axis. So now this is X, Y, Z. We see it's not smooth, so it's a lot of
Sorry,
misalignment.
Can I interrupt quick, Zishan?
Sure.
Where did you get the slice registration panel from?
Oh, yeah, we can start again. On the main session.
Yeah.
I right-click the image dataset.
Yeah.
There's we have many functions. Yep.
Okay.
Listed as the menu, the context menu. So this is called a slice registration because we're going to register slice by slice. And another is image registration, which is to register two volumes or two images.
Yeah.
Right.
Okay.
So this is a different menu. So we go to that's the slice registration is like a chain. So you will see it here. We could apply many steps. We'll see it very soon. I think this is quite unique for slice registration. The first one I want to try is SSD. So I use the fixed box as the area for computing the SSD. I don't know how much the transition is. I mean, is it small or medium or large? Well, we can judge by experience. Does it move a lot or move a little? For me, I start. Maybe I should start with medium. Yeah, this is the how big every movement will be. Basically, it will move every slice many steps and then calculate the SSD and choose the minimum as the best one. So medium means it will move larger than small. Larger is, of course, it's the largest. So now let's try it. So this is a before, look at this. This is a before the alignment or registration. So there's a lot of misalignment from slice to slice because this is longitudinal the view, and this is above is the original image plane. So the original images of each slice. So let's do it for now. We will see computing. So it's doing the registration slice by slice. And after that, we from this view, we see it's much better aligned. And if we go back to the original view, the image view, if we go through the slices, you will see the drift is much smaller. Then you probably will notice this is oblique, where there's no choose, where we don't know the choose, but we can compensate if this is not what we want, we can compensate this drift by a linear compensator. So so from the method we have this option. This is a compensator for moving every slice by the same by the same factor. So it's called linear compensator. So we can move it to be more straight. So now I have applied two steps or two registration steps here. If we go here, I can add more, and I can go back to either to any of them. Like the first one is this is original, this is after SSD, this is after the linear compensator. I can even add more if I want. If I'm not happy with this, I can add, for example, a mutual information. Let me go back here. I can still use the box, same, and that now this time I set the translation to be small, so the movement will be smaller than last time. From the website, they provided us a super good alignment. Like I don't know how they did it. It says template matching. We also have template matching in Dragonfly. I tried it. Maybe I'm not very good at using that. I don't fully understand how it works, so I didn't get as good a result as they had. Now you see, I applied the one more mutual information, and I also get this problem again. So I applied the linear compensator again to make it more straight. Now I have done 4 steps. If I go back here, I can see this is after SSD, and this is after the mutual information. In addition, so as I said, there's no choose, like how how we align them to be the best. It's evaluated by the operator. So if I'm happy with this, I can save it as, for example, as a new data set. This is for saving output options for how we save the registered new data set. I could replace the old one, the original data set, or I can create a new one. So now I'm going to create a new one. This is the name. Yeah, the original of a data set is very big. It's more than 30 gigabyte, and it's have very high resolution. It's 5 nanometer in XY and 8 nanometer in at Z axis. It's too big for my demo, so I downsampled it to 16 nanometer isotropic. So now I have 16 nanometer voxel size. It's much faster. So this is original one, and this is the registered one. So it's much better. for this like YZ view and the X and the XZ views. Normally, we we will crop it to make it even smaller. So, but I'm not going to crop it now. I would try to do the segmentation by using deep learning. So it's by using the segmentation wizard, by right click the new dataset, which is registered already. So new dataset registered, I right click and start the segmentation wizard. And this is also a new standard workflow. We just want to try with this dataset. I don't know much about cells. What I know only is the mitochondria. So I can add a frame. I paint this as the class 1 as my mitochondria. It's not easy to paint the ground truth for this picture, for these images. You see, you can try, for example, you can try the super pixel. It doesn't get the boundary very well. Even you set up a very high grid, like very big grid, because the boundaries are not always clear. So you see here with the super pixel, it's not perfect. So I didn't use this. I tried a few different tools. Eventually I found that the very basic the brush is good for this. Maybe you can try on your side and tell me if you have better tool to use for painting this mitochondria. So this is what I did for this demo. This one must be, because I can easily adjust my brush size. But on my computer, I have some issue with the brush. I never see anybody else reported it. But see, if my mouse cursor in the center part of my screen, I could increase or decrease my size by pressing the control key and my wheel, using my wheel. But if my cursor is near to the edge of this view, I'm not able to do anything. My brush cannot be resized, which is very weird. I reported. I hope it will be fixed in next version. So this image is a downsampled image. It's not very high quality. It's super difficult to segment because of um, the the signal we want to the mitochondria now. The structure or signal we want to segment is not very clear from the background. So I think this is challenging. I tried it. I didn't. I painted 2 frames. I think I got something not too bad, but I probably need more training data to make it better. So as a demo, I just do it quickly. This is the mitochondria I painted in this frame. So I'm going to use this frame for the deep learning model. So I add everything else as the background. It doesn't matter the names, what names we use. We can rename it as background and mitochondria. Or you see also here, there's a background class here. You can drag a class as background here, but this is not important for training. It's more helpful for painting. It will, for example, if I have a background class set up here, when I remove something, it will be added to, for example, if I remove something from my class, the other class, it will be added to the background same time. It's like the exclusive brush, but now I select only one class. It just automatically added every unlabeled pixel to background, which is here. If you don't have background, of course, you don't have this behavior. So you will, when you remove something from one class, you probably will have some pixels unlabeled. And that's the only thing this does, is it doesn't change anything for the training. Now I'm going to the model. I'm going to add one. I want to use 2.5D because I want more information from the z-axis. I use attention unit as my default architecture for now, for a long time, because I found it's always give me good result. Mm, if well, at least it's as good as the standard unit, sometimes it's better. So this is my default model, and to still almost everything is the same as the standard unit. So you set up the dimension. I use 2.5D. The level, the depth level, I also use 5. Um, Now I set up my model and I'm going to train it. Before that, I want to first I want to see how big patch size should be good for this training. I often use a brush because I know my brush size from here. So I use a brush to see if this size is good to cover the like the one mitochondria. So if it does, or most of them, if it does, it means this patch size is good enough to show like efficient or sufficient signals from the object I want to detect or I want to segment. So okay. If it's too small, if the patch size is too small, you won't be able to see your signal from from one patch. If you see, if for example, if your patch size is this small, you don't see the whole thing. You see only very small portion of the one you want to segment. So that does not help much for the model. So this is how I calculate or how I choose the patch size. I think eventually we will have a grid on screen to show the size, like grid of, for example, 64 by 64, or we can change the grid size to like 128 by 128. That will help us to find the proper patch size. But now we don't have the grid. That's why I use my brush, because I know the size of that. So I'm going to change my model parameter, the patch size to 64. I don't have many frames, so I use very small stride ratio for now. So then I could have more training patches. I use the cross entropy as a loss function, unless my classes is very unbalanced. So like one class is very small compared with the other, I may use dice. Otherwise, I always use cross entropy as default. Um, I can save this as my default. So next time I create a new model, this will be the default settings for the model for the training. I save it as default. I don't do this. I don't want to reduce learning rate, and I don't want the early stopping, because I want to see how it goes for many epochs. I know I want to stop it by myself, and I want to reduce the learning rate by myself, not by the program. because I want to see more epochs. I use this, by the way, I use them if I leave my computer to train up multiple models for like overnight or 2 days. That will help. Those will help. Augmentation, yes, I have only one frame, not much, so I use the maximum 20 times. Now I'm ready to train, and before that, I would like to just add one frame as my monitoring frame. So this frame, I use it for monitoring. Now I'm ready to train. So from here, we can see some informations like what model is being created, is being trained, and how we set up the training parameters, the patch size. The batch size is automatically decided by the program when we use the wizard. That's the maximum batch we can use for our GPU, for my GPU. It means the batch size 128. It means it trained the model with 128 patches at one time. So to give the model 128 patches at one time. And we have from here, we can see this is the total patch count 8,190. This means we have probably original maybe 100 patches. Then we do 20 times augmentation. And also we have strategy ratio less than 1. So we increase the number of patch size from the original number of patches we can cut from the frames. So this total count for training patches are after the data augmentation and the strategy ratio. So keep this in mind. If we change the strategy ratio or if we change the factor for data augmentation, this number will change. The validation patch count, this one doesn't change because this one doesn't take the data augmentation and it doesn't take the strategy ratio either. So this one won't change unless you change the frame, like you add a new frame or you uncheck one frame. So if you change or you increase or resize your frame, your training frames, if you don't change your frames, you won't. This one will not change. Now we see the loss function getting decreased, and the visual feedback. We can see the trend. The model pick up. The model can pick up mitochondria. Not too bad. Most of them have been labeled not very precisely, but it has many false positive, which means the other here is not mitochondria. They also be labeled as. So next frame, we want to reduce this false positive error. So we will add more frame and to include more area from here. So I'm going to stop now because I already trained my model to predict something which is not perfect, but as I expected, it won't be perfect because I used only one small frame. But now I have 2 frames, and I'm going to add this new frame. I have my prediction. Where's my prediction? Oh, it's not. So yeah, if I don't see my prediction from the model because I have not turned visible, I click this. So now it's doing the inference, and it has applied the model to both frames, which I have created. So you see that on the top is the ground truth. The frame 1 is what I painted for training. Frame 2 is for monitoring. So I have nothing painted here. But the prediction by the model, not bad. I think it's of course there are some mistakes we will correct, by retraining the model. So I'm going to use the prediction of the second frame as the ground truth. Of course, I will do some correction. So if I go back to input here, I have to select my frame. Then I can use this arrow to put like to fill my ground truth with the prediction for this selected frame. Now I want to work on my frame 2. I want to do some correction. Of course, uh, okay, let me drag class 2 as my background so I can work on my first class. Everything here should be deleted. There's no mitochondria here. I will delete all of this from my labeling of class 1. This is class 2. This is class 1, but not big enough, so I make it bigger to include the boundary, the membrane for the mitochondria. This one, same. You see the image quality is terrible. I don't know how the model could identify. For even for my eyes, it's not easy. I only see some of them when they are very obvious. Many of them they are not very obvious, and I had difficulty to see to tell if they are mitochondria or not. I would expect to have better result with original dataset, but in that case, I need to have a larger patch size because the resolution is higher, which means the same for the same area, it has more pixels. So for the same size of the mitochondria, it has more pixels in the original dataset. So you have to use much bigger patch size. I would expect to be 128. Everything here is not, so I remove them. This will help us, but by doing this with more training data, with a lot of background, will help us to reduce the false positive errors. I correct this. This is not correct. So I expected the second training, the second round of training will produce a better model. And after that, I will stop the demo for today. So let's try one more time. We could train a multi-class model. Now we have this one. I have only 2 classes, but it's okay. We can, if we want to segment multiple classes, we can train a multi-classes model. All right. Here is a little bit thing I want to say. I don't want my frame to be too big, especially for some areas which are not useful or not very useful. For example, here on the top of this frame, I don't want keep this area because there's nothing here special for me to segment, and also it's very easy for the model to tell this area is the background. So I need only a little bit. So if I'm resizing my frame, so I need to give it a little bit, so then it will learn from this. Oh, this part is background. So it's very clear. The feature is very clear. So I don't need to have too big area for that part. And also I can move some if I don't even want to use the whole. I can I mean, okay. All right, now I see why I don't want this, because if I have the background class here, it has the frame. Okay, the every pixel in the frame has to be labeled. Sometimes I don't want this. For example, I want to remove some from my labeling. If I remove some pixels, those this area will not be used by the training, by the model, because it's unlabeled. But this is my intention. I don't want to use this. I want to reduce my total number of patches without without um like sacrifice my effective areas, which is here. So I have the same um training area for my mitochondria, but I have less patches for training because I removed some useless background. I hope I'm clear. So that's it for this new frame. I want to add one more frame for monitoring. So I have a new one. If I change the frame 3 as monitoring, you see the frame 2 is changed to mixed automatically because we can have only one frame for monitoring. Mixed means it could be used for both training and validation. Training and validation. So it's mixed. Well, you can specify one frame for training only, one frame for validation only, but very often we just leave them as mixed. Now I can retrain and we'll see how it goes. We have 5 minutes for the web session. So hopefully we can see something. Okay. I probably need a few more epochs to see the progress. Well, before we finish today's meeting, does anyone have any questions or anything to discuss? It's all right if you don't have anything. As I said, you see here, the total patch size has been increased a lot. And also the validation patch count also has been increased also because I added one more frame. So so we have 2 frames now, which means we have more patches for validation and more patches for training. You see the batch size doesn't change because it depends on my GPU, like the memory of my GPU. So it can handle 128 patches at one time, and we have those patches. This number of patches divided by 128 is the numbers of steps here. You see here the total steps is 79. It means one epoch is 79 batches, and one batch is 128 patches. And I have total number of 10,000 patches here. All right, I think the model is getting better. If you look closely to this, most of the mitochondria here has been labeled more precisely than last time. Of course, there are still some errors. I would say probably we need one more frame or 2 more frames. And also we can try add another model like the standard unit or the same attention unit but with different level depth level But there are many things you can try to get improved for the model performance. And after that, if you have multiple models, we have a tool for evaluating, like to compare multiple models for the same data set. So which one produces the best prediction based on the dice coefficient. So I think the model is keep it's getting better. You see from here, from the earlier epochs, it has more mistake here, but with the last epoch so far, this one, it has no mistakes here. You still have some in the other areas, but it's getting there. All right, so I think that's all for today's demo. We have 1 more minute if anyone has any question. All right, so thank you everyone for joining today. We'll do another one the next weekend, next week, next Wednesday. I hope I could send you an email as a reminder before that. Thank you for joining. Bye-bye. Good night.
Thank you. Bye-bye.